In this video, we are going to present the research and implementations that have been done in employing crowdsourced geographic information for routing and navigation of people with impaired mobility. For more than 5 years, the GIScience research group at Heidelberg University has been developing Open Route Service, a web service that allows the computation of routes based on OpenStreetMap data. There are several routing profiles available, such as car, pedestrian, bicycle, and truck. For the purpose of the research presented in our chapter, we have extended Open Route Service to support wheelchair transportation mode. In this video, we have selected a navigation example of how a pedestrian and a wheelchair user reach a certain destination from a given point in Heidelberg. As can be seen, in the case of pedestrian, the service shows a path passing over a small bridge. For a wheelchair user, however, the route suggestion has changed in a way that tells the navigator that they should completely change his or her direction to the east in order to pass through the main bridge and then head back west to reach the destination. The main reason for this is because the smaller bridge here can only be crossed via steps, which makes it inaccessible for wheelchair users. Therefore, Open Route Service suggests another passable route for the wheelchair user. This functionality is not available in other routing services such as the famous commercial service Google Maps. The advantage of using crowdsourced geographic information over other data sources is that features that are relevant for pedestrian and wheelchair navigation can be collected by volunteers as opposed to waiting for the information to be collected by authoritative organizations. Furthermore, in Open Route Service, you're able to perform accessibility analysis, meaning that you can estimate how far you can travel within a certain amount of time. In this example, I have selected my transportation mode as wheelchair, and I'm interested to know how far I can get from here in 15 minutes traveling time. I would also like the visualization graph being generated based on 3-minute time intervals. Coupled with other services such as Wheelmap, which shows accessible places based on crowdsourced geographic information, this service may answer the question whether a wheelchair user can reach an accessible pharmacy within a certain amount of time from a new place of residence. An important issue that needs to be considered here is the level of data completeness, since the quality of all computations is only as good as the quality of the underlying data. The routing service can only generate routes based on the data that is available in OpenStreetMap. In our previous wheelchair routing example, if the information about the steps of the small bridge was not mapped into the OSM database, then the routing suggestion would have been completely different and of course incorrect or inefficient. In order to improve the level of data completeness in OSM regarding sidewalk attributes, we have extended an open source tool called OSM Quality Assurance Editor. This tool allows you to query sidewalk attributes in a given region of interest and visualize the presence of certain attributes per object. For instance, here I've queried all roads in a given region in Heidelberg where there is no information about sidewalks in the OSM database. Furthermore, the tool allows for the selection and updating of information for certain objects directly into the OSM database. Within the CAP4Access project, we have experienced the usage of this tool in various mapping events. For more information about the results of CAP4Access project, please visit the website www.myaccessible.eu.